Hey mathletes, how you doing out there? Missed you today. All right, let's do the homework for 2C-5. A high school drama club is putting on their annual theater production. There is a maximum of 800 tickets. Now, maximum. It's important. We know there's only 800 tickets for the show. All right, you can't fit any more people in there. Now, the cost of the tickets are as follows: $6 for before the day and $9 on the day. Okay, so we know there's a maximum of 800 tickets for the show. There's two different types of tickets. All right, so those 800 tickets is composed of some tickets sold before the day and some tickets sold on the day. And this final piece here: to meet the expenses of the show, the club must sell at least $5,000. Now, in class, we should have spoken about these words, these key symbols. Maximum. The symbol that goes along with maximum is less than or equal to, all right? Because you cannot exceed that. You cannot go over that number. So, for instance, 800 tickets. You cannot have a number of tickets that is over 800. It has to be less than or equal to 800. Now, for the money, you need to sell at least $5,000 worth of tickets. You can sell over $5,000, but you need to be greater than or equal to that amount. Okay, so there you go. Now, first we're going to write our let statement. We're going to let X equal the number of tickets sold before the day. Okay, and then Y is going to be number of tickets on the day of the show. Oh, very neat. Some of my best work here. All right, so my system. First, we're going to write an equation that talks about the quantity, the number of tickets. Okay, so we know X is the number of tickets sold before plus the number of tickets sold on the day, and it has to be no more than 800. So that's going to be less than or equal to 800. Okay, so between those two types of tickets, we can only sell up to 800 tickets. Now, the second equation is going to talk about the money. I have two different types of tickets. And I know my on-the-day tickets are $9. So I also have before the day. Those tickets are worth $6. So between my before-the-day tickets that are sold and my on-the-day tickets that are sold, I need to make at least greater than or equal to $5,000 to be able to meet the expenses of the show. So these are the two constraints, the parameters of this problem. Now, the club sells 440 tickets. Let's pause for a second. What's the maximum number of tickets we can sell? 800. So if the club sells 800 tickets before the day of the show, how many are left? So we have 360 tickets left to sell on the day. Let's hope that 300 people are walking through this door on the day of the show. Okay? So now, if I know that there are 440 tickets sold on the day, remember that's before the day, that's X, and there could be a maximum of 360 tickets sold on the day. All right? Let's see if we can actually meet that $5,000 mark. So I'm going to take my equation that talks about the money, all right, and I'm going to plug in those two values. All right, I know that we sold 440 before the day. I'm just seeing if I sell my maximum amount of 360, will that be greater than or equal to 5,000 Zolas? So when I put it in my calculator, I get that this is $5,880, and that is greater than or equal to 5,000. So we have showed that if 360 people show up, okay, it will be possible for them to meet the expenses of the show. Yes, it is possible. Okay? Pause the video now. Write down any questions that you have to go over with me in class. All right, for this one, we're just graphing the system of inequalities on the given graph and answer the question based on your graph. So we already have one in slope-intercept form, so that's going to be nice and easy to work with. All right, we know the slope is negative 1/3. That means down 1/3. Our y-intercept is 2. Our line is going to be dotted, and the shading will be, what do you think? Down. Okay. Now I'm just going to put this next inequality in slope-intercept form. Okay. So now it appears that my slope is 4/1, which means up 4, right 1. My y-intercept is -6. Since there is a line underneath here, this is going to be a solid line. And we're going to shade up. Okay, so I'm just going to graph the first line in red. Okay, so that is my first inequality, graphed, labeled, and shaded. Let's do the next one. And here is the graph of y is greater than or equal to 4x minus 6 with a solid line shaded up. All right, now we are going to indicate that this here is the solution set with an S. State a point that is in the solution set for the system of inequalities. It could be anything. So it could be this one too. Okay? So that is -3, -4. All right, just to make sure, let's justify this by plugging it in to both inequalities, into the original. So I have y is less than -1/3 x plus 2. And I have -4x plus y is greater than or equal to -6. And I'm just going to plug everything in and make sure it works out. All right, when I plug it in, I get, is -4 less than -1/3 times -3? That is +1. 1 plus 2. Is -4 less than +3? Yes, it is. So it works for that equation. Let's just plug -3 and -4 into x and y over here. Okay, so I plugged it in. -4 times -3 is +12. 12 minus 4. That is going to be +8. And 8 is greater than -6. So this solution works for both inequalities. Therefore, this is in the shaded area. All right, guys, that's all I got for you. Have a great day. See you tomorrow.